This is questions 1, 7, 12, 17, 22, 24, 26 and 27 from exercise 7.3 in Project Maths 1. In the questions we have to solve the equation. Now solving an equation like these means getting to a point where on one side of the equals we have just our variable, just the letter that we've got involved. In most cases it'll be x, but it can be other letters in other equations. And on the other side of the equals you have to have just a number. In other words, we're finding a value for the letter that will satisfy the equation. And satisfy the equation means that if you put the value back in, you will get the same thing to one side of the equation as you have to the other. Now, let's take a look at the first question. We'll go through this bit by bit. So we've got 5x is equal to 10. So what we're going to do is we're going to try and get x on its own. So we have to move this 5 to the other side of the equals. And when we do that, we've got to change it from what it was on the left to the opposite of that on the right. So on the left here, this is x multiplied by 5. So if we move the 5 over, multiply by 5 becomes divide by 5. So we get x is equal to 10 divided by 5. So x is equal to 2. You notice that we didn't change it from a positive to a negative. It was enough to change it from a multiply by to a divide by. We didn't have to change it from plus 5 to minus 5 or anything like that. And we got x equals 2 as our value in the end. So that is the root of that equation, and that is the solution to that equation. Let's look at question 7. In question 7 we've got minus 7x is equal to minus 21. We're going to follow the exact same move that we did from question 1. So our next line down is going to be x equals, and it's going to be minus 21 divided by minus 7. So we just took our minus 7 and brought it across the equals, and because on the left it was x multiplied by minus 7, on the right it became a divide by minus 7. So minus 21 divided by minus 7 is equal to 3, because a negative number multiplied by a negative number is equal to a positive number. So that one works out. In question 12, we've got 5x is equal to minus 15. Again, we're going to follow the exact same steps we just made for the previous two. We're going to take our 5 across, and on the left it's multiplied by 5, so on the right it's going to be divide by 5. So we get x is equal to minus 15 divided by 5, which means x is equal to minus 3. Because a negative number divided by a positive number is a negative number. So those are the roots to those three equations. But those aren't too difficult. We'll take a look at the next next three questions, and they're a little bit less easy. We'll look at 17 first. We have 7x minus 5 equals 16. And what we have to do in a situation like this is we've got to move things away from our variable, from x, one step at a time. And the first thing you move away from it is any term that doesn't have a letter in it. In this case, the minus 5. So we're going to take our minus 5 and bring it across to the other side of the equals, away from our x. Now, this is a minus 5 on the left. So when we bring it across the equals, it's going to become a plus 5. So our next line down will be 7x is equal to 16 plus 5, like that. Which means that 7x is equal to 21. And now we're going to follow the same process that we did for the questions above. We're going to take our 7 here, which is multiplied by 7 on the left hand side, and bring it across to the right hand side, and we get x is equal to 21 divided by 7, which means x is equal to 3, like that. Let's take a look at question 22. Now in 22, our x is on the right hand side, so we could leave it on that side and move all the numbers to the left. But since we've been keeping the x's on the left so far all the way along, we'll do that. So what we're going to do is we're going to make two moves in the first go. We're going to move our positive 3x to the left, and we're going to move our positive 10 to the right. When we move that 3x over, it's going to become minus 3x. And when we move that 10 over, it's going to become minus 10. So they just changed to a minus because both of them were positive to start with. From here we're going to do out the sum on the right. We get minus 3x is equal to minus 9. And now we're going to make the same move we've made at the end of all the previous ones. We're going to divide by the number in front of x here. So we get x equals minus 9 divided by minus 3. So x equals 3, like that. And just to show how it would have been done if we'd gone the other way, if we left our x on the right hand side, we would have brought the 1 over, and we would have had 10 minus 1 equals 3x, which means that 9 is equal to 3x. Then we're going to bring our 3 over, it stops being multiplied by 3, becomes divided by 3. We get 9 divided by 3 is equal to x, so we get 3 equals x. And this are the exact same solution. Absolutely fine if you'd gone that way with it. It's just more obvious that we go with the top one because we usually keep our x to the left. It's just how things are typically done. Now for 24, we have 5x equals 12 plus 8x. The first thing we're going to do is we're going to move our 8x from the left and bring it over to the right. We're going to have 5x, and then it stops being plus 8x and becomes minus 8x. And that's still equal to 12. 5x minus 8x is minus 3x. That's still equal to 12. And now we've got x multiplied by minus 3. So we're going to bring that multiplied by minus 3 across, and it's going to become divided by minus 3. So we're going to get x equals 12 divided by minus 3. So x is equal to minus 4. Because a positive number divided by a negative number will give you a negative answer. That's 24. Now we'll take a quick look at these last two here. These two are a little bit more involved than the previous ones. There's a few more steps to get done all at once. In each of these we're going to move our x's to the left and we're going to move the numbers to the right and work from there. And the first one, that minus 4 on the right has to be moved over to the left, and this 14 on the left has to be moved over to the right. We get our next line will read 2x, and when we bring that minus 4 over, it's going to become plus 4x. And then we still have our 26 on the right, and we bring that plus 14 over, it's going to become minus 14, like so. So 2x plus 4x is 6x, and 26 minus 14 is 12. And now we take that multiplied by 6 and we bring it across, and we get 12 divided by 6, which means x is going to be equal to 2 in this case. And then we look to 27 and finish this out. We're going to bring our 2x over and our 40 over. 2x comes over and it becomes minus 2x. And when the 40 goes over to the right hand side, we get minus 10 minus 40. 7x minus 2x is 5x. And minus 10 minus 40 is minus 50. Then we bring that multiplied by 5 over and we get x is equal to minus 50 divided by 5, which means x is equal to minus 10, like that. Now we're going to take a quick look at what we can do with these. If we're unsure about our answer is, we're going to take a look at 26 and we're going to check that our answer actually works. And the way that we do that is, we take our solution and we put it back into the equation and check that it satisfies the equation, which means that we get the same thing on the left hand side of the equals as we get on the right hand side. So instead of 2x plus 14, we've got our value for x, so it's going to be 2 times 2 plus 14 is equal to, and then instead of 26 minus 4x, we're going to have 26 minus 4 times 2. On the left, we have 4 plus 14, and on the right we have 26 minus 8. 4 plus 14 is 18, and 26 minus 8 is also 18. So we can be fairly confident now that x equals 2 is definitely the root of that equation. We've definitely done it right because 2 satisfies the equation and we have checked that out. And that is that.